Okay, a set can be really just about anything. You know, we usually, of course, we're in math class, math course. Usually we're thinking sets of numbers, but sets can be just about any kind of collection of objects. You can have a set of numbers, but you can also have a set of students or a set of objects. It can be just about anything. Now, the one thing they like for us to point out here is we do want them to be well-defined objects. So a set is just a well-defined collection of objects. Things. Here's what I mean by well-defined. What we like for the set to be is a set that's reproducible by anyone that sees the set. For example, if I said the set of integers less than 10, between -3 and 4. Okay, so as long as you know what integers are, which they're the whole numbers and the negatives of the whole numbers and 0, but that's, everybody knows what that is. And so that's what we mean by well-defined. It's reproducible, everybody gets the same set out of the thing. What we try to avoid when we're talking about sets in math is something that's not quite as clear-cut. Like if I said the set of good numbers. Well, you know, you may have in mind something that's a good number, but the next person may not think the same thing is. So that's not well-defined, okay? So that's what that means about the well-defined there. Now, as far as notation goes, what we use for sets is name-wise is we give them uppercase letter names. So set A, set B, those are good for a set, good names for sets, we'll call them. All right, then if we use kind of a listing method, we're going to use for grouping symbols, we use the little squiggly line. And let's just say set A is 1, 2, 3, 4, 5. Set B, okay. Set B can be, it doesn't have to be necessarily numbers. So if we use letters for the items here, usually we use lowercase letters, but anyway, so that's just a little bit of notation there. Now, we probably all know the idea of infinite, and you know, let's call set C. All right, let's make set C here an infinite set. 2, 4, 6, 8, 10, ... Okay, so it's the even numbers. So that's an infinite set. Because it doesn't ever stop, it just keeps going. Now the other two here, A and B, are those infinite? No. So what are those? What term for those? Well, if they have a definite start and a stop to them, they're called finite sets. So these first two are finite. So know the difference between those. All right, now here's another notation for you. And that is what we call the objects here. The technical term for those are elements. So set A has 5 elements here. So an element is just an object in the set. And there's a notation for it, like here, 5, and then this, it's kind of looking, weird looking E, I guess. 5, and then that symbol, and then A. That symbol right there means is an element of. So if you see that, just FYI there, that means it's an element of. 5 is an element of. And then of course, if you've got a number or an object that's not an element, well, I could guess that you can see that. 6 is not an element of my set A that I've got listed there. Okay? Now, what I've got here, these is kind of 2 ways of describing sets. This, of course, is our listing it out method. This is more of a word description, right? Set of integers between, and so like here we could say, well, this is the counting numbers up to 5. So I could give that a word description, but we're probably more comfortable with the listing, but there are word descriptions. Now, there's kind of a, I call it a combination of the two, and it's called, and again, just kind of FYI here, it's the set builder notation. So let me give you an example of that. All right, so we got our little set braces, let's call them. Got the yellow squiggly line there, set braces. Then X, and then a vertical line, and then X is a counting number. Less than 50. That's an example of what is called set builder notation. And you could probably figure out what the elements of this set are, but let me just give you some information here. All right, so it's kind of using X as a variable, sort of. But here's the way to read this. This means the set of X, and then that vertical bar there is, you can term that as such that. And then finish X is blah, 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 counting number less than 50, okay? That's what that means, all right? So it's just a fancy notation, I guess, sometimes they like to use. So just know if you see that, that's what that means, okay? Now, one thing I would say about this, okay, so let's write these out. Let's list these out. So it'd be set braces. Which numbers am I talking about? So it's a counting number less than 50, so it would start, where does the counting number start? Start at 1, 2, 3. Well, obviously I don't want to write all those out. I mean, I guess I could, but once you got the pattern established, yeah, you can just use the dot, dot, dot there. And in this case, it's not infinite. We just, what do we go to? It's got to be less than 50. What's the last number then?
49.
49, yeah, all right. Okay, so anyway, those are some introductory things there. Any questions about that?